guys and gals, I am Teacher Ian and I will be your science teacher for this video lesson. In this video, we are going to talk about the law of acceleration and the law of interaction. So sit back, get a ball pen and your answer sheet, and let's start! Your targets. Investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. And infer that when a body exerts a force on another, an equal amount of force is exerted back on it. To test how much you already know about the law of acceleration and interaction, let's try these easy questions. Please get a pen and your answer sheets so that you can write down your answers. Please do not forget to submit all your answers for this video to your teacher. Remember, you can pause the video in each question to give you time to think and answer. Are you ready? Let's start! Select the best answer from the following items, then write your choice on your answer sheets. Number 1. The second law of motion is referred to as blank. A. Law of inertia. B. Law of kinematics. C. Law of interaction. D. Law of acceleration. Number 2. What is the third law of motion? A. Law of inertia. B. Law of kinematics. C. Law of interaction. D. Law of acceleration. Number 3. Which of the following best describes the relationship of mass and acceleration? A. Directly proportional. B. Inversely proportional. C. Reversely proportional. D. Both B and C. Number 4. Which of the following best describes the direction of the action and reaction forces? A. Same direction. B. Parallel direction. C. Opposite direction. D. Perpendicular direction. Number 5. Which of these best describes the amount of action and reaction forces? A. Action force is greater than reaction force. B. Action force is less than reaction force. C. Action force is equal to reaction force. D. Action force is not equal to reaction force. Great job guys! You finished the pretest. Are you ready for more? I hope you are. Let's continue. Word search. Locate the 10 words in the word search puzzle that are related to the second law of motion. Please write your answers in your answer sheets. Activity number 1. Law of acceleration. Investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. For this activity, we are going to make use of a PhET simulation. In this simulation, we are simulating an ideal scenario where there is negligible friction between the floor and the box. We have a box with a mass of 50 kilograms. This dummy will apply the force indicated here. The resulting acceleration of the box will be flashed here. For the first situation, let us apply a 50 Newton force on the 50 kilogram box. Please note the acceleration. Next, let us double the force applied to 100 newtons and keep the mass of the box constant. Please note the acceleration. Guide questions. Number 1. How much was the acceleration of the box when 50 newtons of force was applied to it and the mass was kept constant? Number 2. How much was the acceleration of the box when the applied force was doubled and the mass remained the same? Number 3. How does the force applied to the object affect its acceleration at constant mass? For the second situation, let us apply 50 newtons of force to a 50 kilogram box. Please note the acceleration. This time, let us double the mass of the box to 100 kilograms by adding another 1. Let us keep the force applied constant this time. Please note the acceleration. Number 4. How much was the acceleration of the box when 50 newtons of force was applied to it and the mass was 50 kilograms? Number 5. How much was the acceleration when the mass of the box was doubled and the force remained constant? Number 6. How does the mass of the object affect its acceleration at constant applied force? Keep this in mind. Law of acceleration states that the acceleration of an object is directly proportional to the magnitude of the net force acting on it and is inversely proportional to its mass. The force applied to an object is directly proportional to its acceleration. As shown in the image, a 50 Newton force is applied to a 50 kilogram object. Its acceleration is then 1 meter per second squared. When the force applied to the object was doubled to 100 newtons while keeping the mass constant at 50 kilograms, the acceleration became 2 meters per second squared. This is what directly proportional means. When force is doubled, the acceleration is also doubled at constant mass. For the mass, it is inversely proportional to the acceleration of the object. Shown in the image is a 50 kilogram box and a 50 Newton force is applied to it, resulting to 1 meter per second squared acceleration. When the mass is doubled due to another box being added, making the mass 100 kilograms, while keeping the force applied constant to 50 newtons, the acceleration halved or was reduced to half of its original acceleration. This is what inversely proportional means. When mass is doubled, the acceleration is halved. The law of acceleration can be expressed in a mathematical formula. A is equal to F divided by m, where A is acceleration with the unit of meter per second squared, F is force with the unit of newtons, m is mass with the unit of kilograms. To apply the formula, let us have this sample problem. Suppose a ball with a mass of 0.60 kilograms is hit with a force of 12 newtons. Its acceleration will be blank. To answer word problems like this using equations, let us follow a format for uniformity. Please provide the given quantities, identify the required quantity, write the formula to be used, substitute the values in the solution, write the correct answer, and lastly, the correct unit. This format will give you a total of 5 points. Free fall and Newton's second law of motion. All objects on Earth released from the same height at the same time will reach the ground at the same time regardless of its mass. This is because all objects on Earth are affected by the same gravity. Gravity causes all objects on the surface of the Earth to accelerate when released. This is known as the acceleration due to gravity, and it is the same for all. This means that the velocity of falling objects increase by 9.8 meters per second every 1 second. Circular motion and Newton's second law of motion. Objects moving in a circular motion are still accelerating because of the change in direction. The direction of the force is toward the center. Objects that are moving in a circular motion are still accelerating even if they have constant velocity. This is because they are changing direction. In an object whirled on a string, the force that keeps the object moving in a circular motion comes from the string that pulls the object toward the center of its circular path. If you remove the force by either cutting or releasing the string, the object will continue to move straight and fly off tangential to the path. Apply what you've learned. Solve the following word problems. Please follow the format previously established. Write your answers in your answer sheet. Number 1. A toy car that has a mass of 8 kilograms is hit with a force of 30 newtons. How much is its acceleration? Number 2. How much is the acceleration of a 2.5 kilogram ball hit with a 100 Newton force? Great job! You finished the first activity. Let's move on to the next. Word search. Locate the 10 words in the word search puzzle that are related to the third law of motion. Please write your answers in your answer sheets. Activity number 2. Law of interaction. Infer that when a body exerts a force on another, an equal amount of force is exerted back on it.
Are you ready to play with some marbles? In this experiment, we're going to learn about Sir Isaac Newton's third law of motion. The materials you need for this experiment include marbles and a flat surface. Newton's third law of motion says that for every action, there has to be an equal and opposite reaction. What does that mean? Let's demonstrate it using the marbles. Pick out 2 of your marbles. Place one of your marbles at the end of your flat surface. Roll the other marble towards the stationary marble. What do you notice happens when the 2 marbles collide? The action of the moving marble hitting the stationary marble caused the stationary marble to start rolling. However, there was also a reaction. The moving marble slowed down. That's Newton's third law of motion. The stationary marble underwent an action, getting hit, and responded with a reaction, slowing down the moving marble. Try to set up some other marble experiments to demonstrate Newton's third law. What would happen if 2 marbles collided when they were both moving?
Guide questions. Number 1. When the 2 marbles hit each other, what happened? Number 2. What made the 2 marbles behave the way they did after the collision? Keep this in mind. Law of interaction states that for every action, there is an equal and opposite reaction. There was an interaction between the 2 marbles. Both of them exerted a force onto the other. This is what made them bounce off one another after the collision. The force they exerted are of opposite direction from one another, but the force are of equal magnitude. Another example of interaction is between the nail and a hammer. The hammer exerts a force on the nail, driving it into a board. The nail also exerts an opposite force on the hammer. The direction of the force of the hammer is down toward the nail, and the direction of the force of the nail is up toward the hammer. The forces are in opposite direction but are of equal magnitudes. In this case, the action force is the force of the hammer toward the nail, and the reaction force is the force of the nail toward the hammer. To summarize the law of interaction, please study the table. Apply what you've learned. Identify which option in each item is the action force and reaction force. Write your answers in your answer sheet. Number 1. Dribbling a ball. Number 2. Walking around. Number 3. Jumping off the ground. Number 4. Boy jumping off a boat to the dock. Number 5. Rocket taking off. Great job! You've finished the activities for this video lesson. We're almost done. To help you summarize and reflect on what you've learned on this video, please accomplish these sentence prompts. Reinforcement. Cite 3 examples of applications of law of interaction in real life and identify the action force and reaction force. Please write your answers in your answer sheets. Please do not forget these keywords: motion, acceleration, mass, force, action force, reaction force. Amazing job, guys! We're almost finished. To test your learnings on law of acceleration and interaction, let us answer the post test. Please write your answers on your answer sheet, which will be submitted to your teacher along with all your answers in the previous activities. Please pause the video in each question to give you time to think. Ready? Let's begin. Select the best answer from the following items, then write your choice on your answer sheets. Number 1. The second law of motion is referred to as blank. A. Law of inertia. B. Law of kinematics. C. Law of interaction. D. Law of acceleration. Number 2. What is the third law of motion? A. Law of inertia. B. Law of kinematics. C. Law of interaction. D. Law of acceleration. Number 3. Which of the following best describes the relationship of mass and acceleration? A. Directly proportional. B. Inversely proportional. C. Reversely proportional. D. Both B and C. Number 4. Which of the following best describes the relationship of force and acceleration? A. Directly proportional. B. Inversely proportional. C. Reversely proportional. D. Both B and C. Number 5. What are you going to do if you are to accelerate a bigger mass? A. Apply a lesser force. B. Apply a bigger force. C. Apply an equal force. D. Apply an unequal force. Number 6. Which of the following best describes the direction of the action and reaction forces? A. Same direction. B. Parallel direction. C. Opposite direction. D. Perpendicular direction. Number 7. A worker pushes a large box. Applying law of interaction, how much force does the large box exert on the worker? A. Equal to the force exerted by the worker. B. Lesser than the force exerted by the worker. C. Greater than the force exerted by the worker. D. Cannot be determined. Number 8. Which of these best describes the amount of action and reaction forces? A. Action force is greater than reaction force. B. Action force is less than reaction force. C. Action force is equal to reaction force. D. Action force is not equal to reaction force. Number 9. Which of the following situations does not illustrate law of interaction? A. Rowing a boat. B. A girl floating in space. C. A book on the top shelf. D. When the trigger of the gun is pulled. Number 10. If a utility van becomes loaded with passengers that its mass doubles, what happens to its acceleration, assuming that the same amount of force is applied by the engine? A. It halves. B. It doubles. C. It quarters. D. It quadruples. Congratulations! You finished the video lesson. I hope you learned something. Till next time!